problem, and we actually talked about it a little bit. What keywords tell me which equation I need to use here? Close, keep going. Exponential growth. So I'm going to use my equation. Y equals A e to the bx. What does A stand for? It's my beginning amount. What's B? We don't know what it is, but we do know what it stands for. It's my percent increase. Okay? If it was decreased, then B would be negative, but since it's increased, it's going to be positive. Now, I do know a couple numbers. The 2 and then 125. 2 is the number of days, and 125 is the number of lives. So 125 goes right there. A, E to the 2B. That make sense to everybody? And then I've got another one, and it says 4 days and 350 slides. So 350 equals A, E to the 4B. From here, I always like to solve this one for the letter A. So I'm going to divide both sides by E to the 2B. So I get A equals 125 over E to the 2B. And I'm going to plug it in over here. So that's substitution, right? We're going to substitute that over to this equation. So 350 equals, instead of the letter A, I'm going to write that. 125 over E to the 2B. And I still have E to the 4B. Now some of you asked me yesterday, can I put a 1 underneath here? And I said absolutely. What do I do with my exponents here? Subtract them. When the one's on top and one's on bottom, we subtract. So 350 equals 125. E, 4B minus 2B is 2B. Now we're going to solve that for B by dividing by 125. And 350 divided by 125 is, what is it? 2.8 equals E to the 2B. I'm going to take the natural log of both sides. Or I can change it into natural log, it doesn't matter. ln of 2.8 equals 2B. I'll then divide that by 2. So B equals, and what did we find for B? 0.515. Give yourself several decimals, because that will make this answer over here a lot more exact. So now what we did yesterday is, at the very end of the period, I said plug that in over here and get the letter A, right? So I'll move the recording device. We'll plug it in. So A equals 125 divided by E to the 2 times 0.515. And what do you get there? 44.63. Do you guys agree with Mallory? Okay, that's not 6. There we go, 6, 3. Does that make sense how we got A and B so far? But that's not what it, oh, so what's my starting amount? How many flies did I originally start with? Approximately. Approximately 45, either 44 or 45. And I'm actually increasing by 51% every day, right? Quite a few flies. And actually, if you've ever had fruit flies, if you notice, you'll see like 1 or 2, and then all of a sudden you see like 50.
Why did you go from ln 2.8 to ln 2B? How did you go from that
Remember,
to ln 2.8 to 2B?
remember, ln of E, they cancel each other out.
Well, why would you cancel on the other side then? Because ln base E.
Because I put the ln here, so technically it's ln base E of E. Kind of like when we put the log in both spots, it also cancels stuff out. Or, Ryan, you could have also changed it to exponential, so it'd be natural log base e of 2.8 equals 2b.
Well, I don't understand that because you said it's log. No, log is the same. Log usually have a base of 10. So
Well,
I don't
this
understand how.
e has a base of e.
So does the other one then, doesn't it?
Right, but there's only one e here and then a 2.8. This has two e's there technically.
Okay.
Okay? If that confuses you, change it to natural log by doing the ring around the equal sign. If I do that, I get natural log base e of 2.8 equals 2b. And that's what I wrote right there. So you have a couple options to do that problem. All right. So now it's wondering, the question is, how many flies will there be in 6 days? Well, before I do the answer, I should write an equation. That way, in case for some reason I decide to change it to 60 days, you only have to plug in the number 60. If I decide to change it to 400 days, you can plug in the number 400. So what's the equation I'm going to write, Justin? So 0.515x, right? And then he plugged in the number 6 already in for the x. That's why he said 6 times 0.515. All I have to do once I have that equation is plug in the number 6. So I'll give you a couple minutes to go ahead and do that. Justin already has that answer. Whitney has the answer. So we've got two of you have the answer. But I get what? You're okay? And Justin, what'd you get? 980? Yeah, that's good. And the reason that's good is we're talking about flies. If he gives me a decimal, can I have a point something of a fly? So I'll actually accept 980, 981. Either one's fine. Okay. Now, when you're telling me the beginning number and the ending number, you want to be pretty close to exact. Give me several decimals because that changes this final answer.
Plug in for that.
6. We plugged in the 6 because we're looking for after 6 days. A lot of what? It is. But think about it. When you see like a fly and then all of a sudden they just start multiplying, don't they? They multiply very quickly. Any questions? Did it help you go back and do that a second time, like talking through it? A little bit better? Okay. All right. Here's our next problem. And I'll pause it here while you go ahead and copy that down. So, this is a Gaussian model here. And a Gaussian, we've already talked about yesterday, is a bell curve model, right? And in fact, what I did was I graded your quizzes. And you're going to get the score you got on the top of it. But I also curved your quizzes. So you're going to see what your score would be if I had curved it also. Just, like a little interesting thing just to show you that you probably don't ever want me to curve. And I'll show you that at the end of the period. So, what would I do with this problem to even begin it? And I'm not going to teach it. I think you guys should be able to do this for me. Okay, I think the first step should be in R. Let's do that. So 1 over 10 to the 14th equals 1 over 10 to the 12th. E to the negative t divided by 8, 2, 2, 1. No, 1 over. So all I did was I plugged in R to R. And I know this looks a little weird because I wrote this as an actual fraction, and then I wrote the other part right beside it. So far, okay? What can I do next? Okay, I am going to solve for t, but what do I need to do next in order to solve for t? Do you see a plus sign? So it won't multiply by 10 to the 12th, right? So So if I multiply this by 10 to the 12th and I multiply this by 10 to the 12th, right? What happens right here to the 1 over 10 to the 12th and the 10 to the 12th? They cancel, right? So I'm left with e to the negative t divided by 8, 2, 2, 3. I just rewrote the other crazy stuff. What's left on the other side? What do you do with your exponent? So it would be, okay, I could write 10 to the negative 2, or I could write, either one would be fine with me. Either one's fine with me. I multiplied by 10 to the 12th. And then I just subtracted exponents. 14 minus 12 is 2.
Wait, why did you want all those things?
So that this would go away and I'd be left with the e
So
stuff.
you want like the e5.
Yeah. Yeah, because I need that exponent. But I can't get to that exponent until I take the 1. A natural log. It's base e, I need the natural log. So go ahead and change that to natural log. Change that to natural log. I change it to natural log because the base is e. Could I change it to log? That would be fine also. I'm going to use natural log. Because otherwise I have to use that change the base theorem and I don't like it. So natural log, my base is tell the 10 to the negative 2 or 1 over 10 squared, either way. Same thing, right? Equals negative t divided by 8, 2, 2, 3.
Because the element is the e thing.
Now, I'm not going to do anything in my calculator yet. How do I get that t by itself? What's the next step?
Multiply by 8,223.
So I have 8,223 times. Natural log, you know what, Whitney, I'm sticking with your 10 to the negative 2. Why not? Because I'm just going to switch between them so you guys don't get confused. Equals negative t. Divide by negative 1. Watch my dividing. Are you ready? Done. That's okay just to move the negative sign over because there's no plus sign in there. If I divided by negative 1, positive 8,223 divided by negative 1 becomes negative 8,223. That's all that did.
So then why did your ln times the negative 2 not have a row?
Okay, so think of it this way. 3 times 2 equals negative t. So this would be, if I divide by negative 1, that's the same as negative 3 times 2, right? I don't distribute it to both things. I only distribute it to the one thing. Good question. Now, type that in your calculator, give me t. Let's figure out the age of this fossil.
Why did you take 8,223?
What they actually probably have done is many, many models on this. Ran it through several equations and then finally came up with that. That make sense? What? Actually curve, like use a curving model. Saying you curve and actually curving is 2 different things.
Logical physical.
So once again, say it again.
Hard to say physical.
You guys all think I curve your grade. I've never curved a thing in my life. But you just changed the gradient. It's not considered curving.
When they say they curve something, what is it?
They're adding percentage to your, yeah, when they're looking at the highest percentage, that's different. Alright, so what age did we get? 3, thank you, 7, 8,
Oh,
6, 8. This is a 37,000-year-old fossil. That is. But that's possible, right? AKA dinosaurs. That's where these come from. No, you could actually round that to a whole number. At that point, 0.31 years is not going to matter. All right. Scores on the last math test. Okay, really, that's not true. It's just a problem we're going to try. What was the average score of all the students? First off, it doesn't matter how many students took this last test. That has nothing to do with that model. That model already figures in a total of how many students took the test. Okay? But the average is the middle, right? The middle, 50%. And it's always that number. So the average was a 74%.
wow.
This is actually one of those Gaussian models again. So the middle 50% is always that number. Number before in the, yep, right there. Like I said, I really don't like that one, but just so you see something like that. I don't think so. I don't think it ended up there. All right, this is a type you will see there. So I honestly copied stuff over from Mr. Williams. So we have Williams University. He starts his own university. He starts somehow with 7,500 students. How in the world does he start with 7,500? I don't know. But there's a contagious virus that starts. And the spread of this virus is actually modeled. You know, Mr. Williams had to figure out the model, the one behind it. And they want to know how many students will be infected after 4 days. Let's start with that question. After 4 days. Okay, good. Do that. I'm not trying to trick you here. But we got to start somewhere basic where you're not panicking immediately, right? It looks like there's a lot of stuff going on, but all you really have to do is to plug 4 into T. Go ahead. So I'm not going to write down any work. My guess is you wrote down the equation, you plugged in the number 6, and it sounds like a few of you did it all in the calculator, which is fine. How many students are infected after just 4 days? 36. So after 4 days, we have 36 students. They're sick. Well, the college actually closes down when 30% of the students are sick. High schools actually close down once a certain percentage are sick. So 30%, how would I go about doing and figuring out how long before? Brandon, what do you think?
On 30% of 7,500, and then divide that by the day.
You're kind of right there. He's really close. We will be solving for T. You're really close, Whitney. Well, no. We're not going to change anything in the equation itself. We will be solving for T. But, so why is the total number of students infected, right? Actually, Brandon, you're right. Sorry, I was thinking I was going to multiply by the opposite. So go ahead and multiply. What is my starting amount? 7,500. Multiply that by 0.3. So once 2,250 students are sick, once that many is sick, I need to close the school, right? So I have the equation, 7,500 divided by 1 plus 7, 4, 9, 9, e to the negative 0.0. Okay, a few more two decimals there. 0.09 t. rewrote this because I don't like it this way. I just put the 7,500 on top and that number, whole thing on bottom. Do you want your exponent on the bottom? No. How would I go about like switching things around so that this giant thing's on top? Justin, what? Well, I can't multiply by 7,500. It's on top. If I multiply by 7,500, I'm going to take 7,500 times 7,500. I can cross multiply. Times this, right? And then what am I going to do with the 2250 in the end? I can multiply the 7,500 to the 1. So I'll actually show that work. And I'm going to show you the way I thought of it. Cross multiply. I didn't actually multiply a number at all yet, did I? I'm not picking up a calculator yet. I'm going to move the 2250 over now. So I'll divide by 2250. Now, take a look up here. What do I have on this side? I have 7,500 divided by 2250, right? And over here, I have that giant thing on top. Because I need the giant thing by itself. Now, take a look at what you could have done to save yourself from writing this entire step. I can take this and this, switch them. Remember we talked about that before? And some of you said, oh, it's kind of confusing. So you can write it all out and divide. Or you can just take these two and switch them. You choose, it's fine. If you don't like that whole just switch, you can cross multiply and divide, and that's fine. It's not wrong. Okay, 7,500 divided by 2250, what do you get? 3/3? 10/3. I thought somebody said 3/3 there. So 10 divided by 3 equals 1 plus 7,499 e to the negative 0.9t. What's next? Not yet. I can change it to ln, Whitney, once e is by itself. Subtract 1. 10, 9, 8, 7. So 7 over 3 equals 7,499 e to the negative 0.9t. Just so you know, these parts right in here are Algebra 1 again, except with crazy numbers. Okay? So divide by 7,499. Again, Algebra 1 with crazy numbers. I'm not saying it's easy. I'm saying it's basic math, right? With crazy huge numbers. I have no clue what 7/3 divided. Oh. Okay, leave that in your calculator. 3.1115. Wait, you can't just write that. Because it's times 10 to the negative 4th, right? Notice you have an e negative 4 on yours? In your calculator? Do you see the e negative 4? Okay, do it in your calculator. Leave it in your calculator. Don't delete it. Don't delete it, okay? You okay if I delete all this stuff? Just so we have some room? Alright. Now got e by itself. Change it to natural log. So it'll be natural log base e of 3.1115 times 10 to the negative 4 although you're not going to have to actually write that down or type that ever again, equals negative 0.9t, right? So how do I do this in the calculator without typing 3.115? I don't want you to type that. How would I do that in the calculator? Well, you can't, what? Say it again, Trevor. Yeah, second answer will pull that up. So you hit the ln key, and then do second, and I think it's the minus sign gives you the answer, right? Okay, and hit enter. That's the natural log of 3.115 times 10 to the negative 4 without you ever typing it again. That way, have you ever messed up typing? You can just do it then. Calculate for the equation. What is it? This is science teacher equation for us. For instance, it's actually times 10 do that. So yes.
I'll put the math and then second underneath.
Second negative sign. All right, now we need to do one more thing. What do we do? Now, I don't want to have to type all this other stuff in, so how do I do that in the calculator? Actually, if you just hit the divide key, up came ANS first, didn't it? It knew to take that answer, and now you can type that negative 0.9. So what do you get? So 8.97, which means if this flu or whatever virus it was continues, in 9 days that college must be shut down. Nobody is allowed to come and teach on that campus. Wow is right. Yeah. I didn't mean it that way.
What?
I think you guys are giggling because I said it.
Yeah.
No,
Yeah,
I didn't mean it that way. No, I was like, all right, Training Modern. All right. All right, answer. Hopefully you got 7.83. Because you knew to plug in that number to I and then you just type it in the calculator. Okay? Hey, by the way, what a log does is it takes an enormous giant number in intensity and puts it to a regular number that we understand. So like if you hear of an earthquake that's a size 5, you know that it's not near as strong as a size 8, right? That's a huge difference because this number here grows hugely. But that number's pretty easy to read, isn't it? That's why we like logs. We take big numbers and make them small and normal. All right. Homework. 6 problems.